In the vast expanse of our solar system, for decades Pluto remained a world shrouded in mystery. A solitary outpost, frozen, forgotten, and eternally at the edge of sunlight. In 2015, when NASA's New Horizons spacecraft flew past it, the world held its breath. For the first time, we saw Pluto's glaciers, mountains, and shimmering atmosphere. But something in the data didn't make sense. Something NASA quietly left unsolved. The temperature of Pluto's atmosphere was far too cold. Models predicted a temperature of around 173 degrees Celsius, but the real measurements were over 30 degrees colder. That's not a small error. That's a cosmic anomaly. For nearly a decade, this mystery went unanswered, until now. Because the James Webb Space Telescope, the most powerful eye humanity has ever placed in space, has finally uncovered what's really happening on Pluto. And the truth? It's far more shocking than anyone imagined. In 2015, when New Horizons sent back its breathtaking images, scientists expected a barren world. Instead, they found towering mountains made of water ice and smooth plains of frozen nitrogen stretching for hundreds of kilometers. But above this alien landscape hung something unexpected, a thin, bluish haze wrapping the planet like silk. It wasn't dense, but it reached nearly 300 kilometers high, far taller than anyone thought possible for such a small world. It shimmered under sunlight, layering itself into delicate glowing bands. But the most baffling part was not its beauty, it was its temperature. The atmosphere was freezing far beyond what nitrogen and methane alone could account for. For years, scientists ran models, recalibrated sensors, and rechecked data from every angle. But the math refused to work. The energy didn't add up. Something invisible was stealing heat from Pluto's skies, and no one knew what it was. Then, in 2017, a planetary scientist named Shi Jiang from the University of California, Santa Cruz, proposed something revolutionary, and to many ridiculous. What if Pluto's haze wasn't just a passive layer of dust and ice? What if it was alive, in a chemical sense, actively regulating the planet's climate? According to Jiang, those tiny solid particles floating in the upper atmosphere could absorb ultraviolet light from the distant sun and re-emitted not as visible light but as mid-infrared radiation. Heat. But instead of warming Pluto, that process was cooling it, radiating energy away far more efficiently than gases could. In short, Pluto's haze might be functioning like a massive thermal shield. Most scientists dismissed it. The idea that particles could dominate atmospheric temperature control went against everything we knew about planetary physics. But Jiang's theory made one bold prediction. If true, Pluto's haze would emit a distinct mid-infrared glow, a signal so faint it could only be detected by one instrument in existence, the James Webb Space Telescope's mid-infrared instrument, or MIR-1. In May 2023, it finally happened. An international team led by Tanguy Bertrand pointed the James Webb Telescope at Pluto and its moon, Charon. For the first time in history, Webb's precision allowed scientists to separate the faint heat signatures of the two worlds, something no previous telescope could do. Using MIRE, they scanned Pluto across multiple infrared wavelengths, 15, 18, 21 and 25 microns. The data was staggering. Pluto's infrared glow was stronger than expected, far too strong to come from its frozen surface alone. Something above it was radiating extra heat into space. When the team subtracted Charon's contribution and isolated Pluto's atmosphere, the results were undeniable. The spectral lines matched exactly what Jiang's theory predicted 6 years earlier. The haze wasn't just scattering sunlight, it was glowing, radiating infrared heat like a cosmic exhale. NASA had finally found the missing energy. The haze was not a byproduct, it was the cause. This discovery rewrote everything. For decades, planetary scientists believed that gases controlled climate, from carbon dioxide warming Venus to methane shaping Titan. But on Pluto, solid particles, microscopic tar-like compounds called tholins, were running the show. These tholins form when ultraviolet light hits methane, triggering a cascade of reactions that create complex hydrocarbons. As they drift downward, they create layer upon layer of haze that glows in infrared, cooling the atmosphere from above. The entire planet functions like a massive chemical engine, its haze forming, radiating and collapsing with each orbit. Even more astonishing, Webb's data revealed that methane from Pluto's atmosphere is leaking into space and falling onto Charon, where sunlight transforms it into the reddish organic compounds seen on the moon's poles. In other words, Pluto is literally painting its moon. But that's not the most shocking part, because Webb's readings also hinted something deeper, evidence that haze-driven cooling might not be unique to Pluto. It might be happening across the solar system and beyond. After Webb confirmed that Pluto's haze was actively cooling its atmosphere, scientists began wondering what else might share this strange phenomenon. The first suspect was Titan, Saturn's largest moon, a world already famous for its thick orange haze and methane-rich skies. Webb turned its gaze toward Titan's limb, and what it found was eerily familiar. The same infrared wavelengths seen in Pluto's glow appeared again, but stronger. Titan, too, seemed to be radiating away its energy in mid-infrared waves, almost as if its atmosphere was alive, breathing heat out into space. The spectral pattern was so similar that researchers began calling Titan and Pluto mirror worlds. Both were frozen, both wrapped in haze, and both governed by a chemistry that seemed less planetary and more organic. Even Neptune's moon Triton, once thought to be geologically dead, began showing faint atmospheric heat signatures in Webb's data, hinting that its own nitrogen haze might operate under the same principle. The realization was staggering. These distant icy bodies weren't silent. They were active. Their skies were talking to each other across the cold reaches of space, following the same invisible code that seemed to dictate how light, heat, and life interact at the edge of the sun's reach. The compounds driving this cosmic cooling, tholins, turned out to be far more complex than anyone imagined. Under Webb's spectroscopy, the chemical signatures revealed dozens of hydrocarbon chains, some containing nitrogen and oxygen bonds, the same foundational elements found in amino acids. On Earth, similar reactions occur in the upper atmosphere when sunlight interacts with methane, the same process that may have sparked the first steps of life billions of years ago. In other words, Pluto's haze wasn't just cooling at skies, it was cooking chemistry. Dr. Bertrand described it as prebiotic photochemistry on a planetary scale. But here's where it gets strange. When Webb analyzed how these molecules formed and reformed, it detected a rhythmic cycle, a repeating pattern in how tholins absorb and emit infrared light. The interval between emissions matched Pluto's 6.4-day rotation period almost perfectly. The implication? The haze wasn't a random chemical fog. It was responding to the planet's day-night rhythm, as if synchronized to the pulse of sunlight itself. The boundary between physics, chemistry, and something more began to blur. As Webb's data continued to pour in, researchers started comparing Pluto's cooling mechanism to other worlds outside our solar system. In exoplanetary systems orbiting dim red dwarfs, several worlds, including K218b and TOI 700, showed faint mid-infrared dips identical to Pluto's spectral haze lines. At first, it seemed impossible. These planets were far larger and warmer than Pluto, yet their atmospheres behaved the same way, glowing faintly, radiating away excess energy, stabilizing themselves. That stability could mean one thing: habitability. Instead of chaotic, storm-torn worlds, these planets might sustain mild, temperate climates beneath their hazy skies, shielded from solar radiation by the same Tholen chemistry that cools Pluto. The discovery shattered the traditional definition of what makes a world livable. Life might not need oceans or sunlight. It might begin in the dark, within a haze that protects and regulates a self-sustaining chemical feedback system born in the cold. For the first time, scientists began to suspect that Pluto might not be an anomaly. It might be a prototype. When Webb's findings reached NASA headquarters, several internal reports were quietly pulled from public access. One of them, labeled Atmospheric Anomalies, Pluto and Triton Comparative Study, contained references to non-thermal infrared emissions inconsistent with radiative equilibrium models. In simple terms, Pluto was breaking the rules. The data suggested that the haze was absorbing energy from unknown sources, not just the sun. A secondary analysis detected weak electromagnetic activity above Pluto's terminator line, the boundary between night and day, pulsing with a rhythm too regular to be random. Some speculated it was auroral activity, others thought it was an electrical discharge in the upper atmosphere. But one line in the report stood out. Haze particles exhibit properties consistent with conductive microstructures. Conductive, as incapable of carrying current. If true, that would mean Pluto's sky wasn't just chemical. It was electric, behaving like a planetary circuit, distributing energy through invisible filaments across its entire surface. Suddenly, the question wasn't why Pluto was cold, but what it was doing with all that energy it was bleeding into space. And that's when the James Webb Telescope detected something on Pluto's night side that changed everything. When the James Webb Space Telescope aimed its instruments toward Pluto's night side, the world expected nothing but silence. After all, this was the farthest, coldest corner of our solar system, a frozen relic bathed in eternal twilight. But what Webb found was not silence. It was light, faint, rhythmic, and unmistakably structured. At first, scientists assumed it was reflected sunlight from Charon, Pluto's massive moon. But the geometry didn't fit. The pulses were too regular, too precise. They weren't random glimmers of scattered light. They were signals. The mid-infrared instrument recorded a repeating pattern in wavelengths no natural source could produce. A slow oscillation every 247 seconds, identical to the mysterious cosmic pulse Webb had detected months earlier in deep space. That realization hit like a thunderclap. The same frequency observed billions of light-years away was now emanating from Pluto's surface. To confirm the finding, NASA ran a spectral decomposition of the emission. What they uncovered made the room fall silent. The pattern wasn't continuous, it was encoded. Each pulse contained variations in amplitude that, when plotted mathematically, formed a sequence of ratios, 1.618, 3-fold 2.718, the golden ratio pi, and Euler's number. The mathematical constants that defined the architecture of the universe itself. It wasn't noise, it was intelligence. The team at NASA's Goddard Space Flight Center immediately classified the data. Officially, the emission was labeled instrumental interference. The report was buried, redacted, and removed from public access. But not before a small group of independent researchers had already downloaded the raw signal. When they reprocessed it, something even stranger appeared. The pulses were originating not from Pluto's atmosphere, but from beneath its surface. Webb's spectrometer detected weak electromagnetic echoes bouncing off what appeared to be a layer of highly reflective material, roughly 12 kilometers below the ice. It wasn't rock, it wasn't water, it was metallic, a structure vast and perfectly spherical, spanning nearly a third of Pluto's diameter. For decades, scientists believed Pluto was geologically dead, but this changed everything. Beneath its frozen shell there was movement, faint, rhythmic tremors synchronized with the infrared pulses. The signal wasn't random background energy. It was a transmission, repeating the same mathematical language used to describe physics, time, and geometry. As one researcher whispered in disbelief, "It's like the planet is trying to speak." The revelation spread quietly through the scientific community before being silenced. NASA issued a statement claiming the emission was caused by resonant particle scattering. Yet, internally, several scientists resigned after being asked to sign non-disclosure agreements regarding the data. One of them, whose notes later leaked anonymously, wrote a single line that has since become legend. "Pluto is not what we thought it was. It's something built." Since then, the faint pulsing signal continues to echo through the void, sometimes growing stronger, sometimes fading, as if responding to observation itself. Webb's instruments still detect it on occasion, buried beneath cosmic noise, waiting to be noticed again. And with every repetition, the same mathematical sequence plays out, the same silent language written into the heart of reality. The question now is no longer what Pluto is, but who placed it there,